Morning, folks. Today I'm in sunny Cocoa Beach, Florida. I'm here to watch a resupply mission launch from the NASA launch pad at Cape Canaveral. But I wanted to make some time to show y'all around the image processing pipeline app that I'm working on. This video won't be super long because truthfully the internet connectivity here isn't such that I could stream for 3 or 4 hours with y'all like I typically do. But I wanted to show you around this app a little bit because it's an app that we've talked about in the past. It's an app that's super interesting, and it's also something that I'm likely to continue working on live coding with you all. So if you have followed the blog, then you may be familiar with this app. I've called it Theia in the past. I'll put some links down in the description where I've talked about this app in the past, how it came to be, what it's supposed to be used for. The short version is that this application processes images. And it doesn't just process any images, it processes very large and complex images. It's been designed specifically to process images from NASA Landsat satellites. So we have satellites that circle the globe that take pictures of the Earth's surface. They take those pictures in these very large tiles, and those tiles contain a whole lot of data. Now, to call it a picture is a little bit inaccurate because they actually collect data from a whole bunch of different wavelengths of light, including visible and invisible wavelengths. And so we can make a picture with some of the channels of data that we receive, like red, blue, and green. We also have access to ultraviolet channels and infrared channels. Just so happens that our foundation client for this application is looking for kelp growth along the coastlines of continents. And so they happen to be using visible light wavelengths, red, blue, and green from the NASA Landsat data. So if you see red, blue, and green in this application, then that is what you're seeing. I want to show you a little bit about how this app works. So let me show you where I have it running right now. Here's where I have it running right now. So this application is a Django-rest application, and the UI that you're seeing here is the UI that comes standard with Django-rest applications. So this is the screen where we would make what's called an imagery request. So let me talk to you a little bit about what an imagery request entails. We have this API for our entire data model. An imagery request is what allows a client to say, we would like to request some images from the NASA Landsat service, and we would like to do some processing on those images. Then we would like you to put our processed images somewhere so that we can look at them for analyzing or for submitting them to citizen science, which is chiefly what researchers will do with this platform. I'm working on this application to help researchers get their process data onto a citizen science platform called the Zooniverse. You may have heard me talk about it. I'll link a video to that down in the description as well. So let's take a look at our data model here for a second. This UI is also given to us by Django-rest, and what we've done here is we've registered our models to appear here. You'll see that we have a URL for imagery requests, which we've talked about. Job bundles are how we ferry the data around between the tasks that we do with the images as we are executing on a request. We'll get to that a little bit more later. It's more of a technical detail. What I really want to talk to you about today is pipelines and pipeline stages. So a pipeline is a series of steps that a researcher can put together to say, these are the processing steps that I want done on each of my individual images that I receive, or each of my individual data bundles that I receive from NASA. I keep referring to them as images because the client that we're working on this with is creating images out of this data. But anytime you hear me say images, I mean that data bundle that comes down that can include visible and invisible wavelengths of light. So the pipeline can be made up of pipeline stages. And I think the best way to illustrate this is going to be with an example. So if I have an image processing pipeline, let's say I want to do some things to the image when it comes down. So first, I want to filter on specific channels, red, blue, and green, to create a visible image. that is one pipeline stage. I want to pass my red, blue, and green stages to the next task, which is to amplify, let's say, the green stage, because I really want to see that kelp pop out in my images. So that's a task. Then we pass our red, blue, and amplified green stages to the next task, which is to compose the red, blue, and green channels together into a visible image. Then in the next stage, maybe I want to increase the contrast on that image. And in the next stage, maybe I want to cut that big image up into little pieces so that we can look at individual pieces of coastline. And then I want to figure out which of those tiles include coastline, because most of them will be a lot of land, most of them will be a lot of ocean, and some of them may even have so much cloud cover that we can't see the coastline at all. So we want to filter for the images where we can see the coastline. Now we have these high contrast, green forward, coastline specific images, and we want to upload those to a citizen science platform like the Zooniverse. That's the last task that we would do in our pipeline. And so the pipeline that I've described has several stages in it, and we can define each of those stages inside of our application. Those stages map to specific tasks, which are also defined within the application, and I'll show those to you a little bit later. Projects here refers to the Zooniverse platform specifically. We have individual projects that might upload images. So for example, our foundation client, the floating forest project, is looking for this kelp on the coastline. And so they would upload all of their images to their specific projects for people like you and me to go onto the Zooniverse website and look along the coastline to see if we see any kelp and to identify that kelp for the researchers. Requested scenes is also a technical detail that we use inside of the application, and so we'll get to it later. For now, I want to show you how we kick off one of those imagery requests. After a researcher has defined a pipeline and all of their pipeline stages, they can go to the imagery request form here, and inside of that imagery request form, we can say, please get me these images from a specific part of the world and run my pipeline on them. So here we're going to choose an adapter. That's going to be the United States Geological Service. We will talk more about those adapters later. Dataset name. There are a couple of different Landsat satellites that we can collect these images from for right now. We're going to use Landsat 8 at the moment. Then we can define a maximum cloud cover. And that maximum cloud cover is going to filter out in the pipeline anything with a cloud cover over this. I've been using 45 as an example. Then we are going to say how many results we want. Now, the service can send us back a whole lot of data, and they're big, big files. We can't necessarily process them all right at once, and so we'll put in something relatively small. Today I'm going to use 2. Researchers tend to use something more like 5 or 10, but this is an example. Okay, so then these 2 labels, they say WGS row and WGS path right now. They actually mean WRS row and WRS path. We'll get into these in a little more technical detail later, but what you need to know is that they are a way to locate on the Earth's surface a specific location. You may have heard of another way of doing this, which is latitude and longitude. The reason that we're not using those is a little bit specific to the Landsat images, but essentially latitude and longitude is one way of slicing up the Earth, but there's bigger distances between latitude and longitude points around the center of the Earth relative to on the poles, and we want to be able to develop uniform squares with the data that we make, and so we have another way of chopping up the Earth's surface that does the stretching of the Earth on a smaller scale, on a tile by tile scale rather than on a globe wide scale, and those are the WRS row and path, and so we're using those here. I'm putting in 23 and 31, and that's solely because that is where Chicago's at, and I'm from Chicago. Okay, so then we put in a project, and we're going to be using example image project and the floating forest replication test pipeline. I've created the floating forest replication test pipeline ahead of time. It's a very limited pipeline in that all it does is it gets the images down from the NASA Landsat service, and then once it has those images down, it takes out the red, blue, green channels, it composes them, chops them up into tiles, resizes all the tiles, and then it puts those resized tiles up onto my example image project on the Zooniverse science platform. So when I make a post request here, let me show you what's going to happen. Inside of our django-rest application, we have these things called ViewSets. Now, you may be familiar, if you've done Django apps before, with the views folder. This is similar to where controllers would live inside of a Rails app, and what you'll see here is a number of ViewSet files. Now, if you've worked with a view-specific application in Django, you would be used to seeing view files there instead of ViewSet files. ViewSet is a tool provided to us so that in an application like this one, which is an API-specific application, we will be able to have some extra functionality available to us. So let's take a look here. Inside of the REST framework, we know we have these view sets. And we see that we're importing the view sets from the REST framework here. We would be able to go to that and see that what those view sets do for us is manyfold, and we'll talk about that a little bit as we take a look at this. You'll notice that this is a very limited view set. This is for the imagery request, and this is where those requests come when we make that post request to say create for me a view set. So what are we doing here? We're getting all of our imagery requests, and we are getting an imagery request serializer as well. This imagery request serializer helps us translate back and forth between JSON and the imagery request that we have defined for our model. So we have our serializer, and now we're going to do the create request. What we do here is we get the data, and then we serialize that data. We determine that the data that we have received in through the post form as JSON is valid for this model, which means that any validations that we have created on our imagery request, which we can look at, all of these validations that you would see. So for example, we're checking our max lengths right here. We're checking that things can't be null, aren't null. That's where we're doing that validation. And then we perform the create task. You'll notice that perform create is a method on self. It is a method on our imagery request view set. It's a method that we actually get from our model view set, which we get from the REST framework. Then we get our success headers from our serializer data, and we return a response to the user as we process our data. Now here's where it gets a little bit tricky, because this looks like just a few lines of code. What's important to us with respect to the task is what's happening with this perform create. We have to look at the imagery request itself to see what's happening here. Inside of our imagery request model, we have all of these attributes defined. We also have a number of methods defined. One of them is our toString method to make it easier when we're printing things out to see what's going on with imagery requests. We'll talk more about that when we talk about debugging in a future post. But you're also going to notice this class method here, post save. What this method does is it runs each time we save the imagery request. And when is the first time that we save the imagery request? Immediately upon creation. So when we do that create step inside of our imagery request view set right here, that method's getting run. And what does that method do? If there is successful creation, we queue up a worker to search for matching scenes and begin getting those scenes down from the NASA Landsat service. At that point, we switch over to a module called Thea.tasks, and I'll show you that. Inside of that tasks module, we have a task called locate scenes. We'll delay it. We are using asynchronous tasks in this application. So here we are inside Thea.tasks. Here is our locate scenes task. What we do now is we get our imagery request up, and then we call a specific adapter. We have a couple. So far, we just have one. We'll change the name of this later, but this is essentially a task that we use for testing. It doesn't do anything. And then we also have our US Geologic Service adapter, which allows us to take information that is specific to the US Geologic Service and perform the filtration that we've talked about on the data that it sends down. Okay, so that's our locate scenes task. Once we have our scenes, we perform our processing, like we talked about with the pipeline stages. Each of those stages is done in what's called a process bundle task. So you could have several process bundle tasks set up, one immediately after the other. And what we have inside of this task is the logic that we use to pass information from one task to the next via the job bundles so that each task has the information it needs to perform the transformations that it needs to perform. The first task will almost always be locate scenes, and the final task will almost always be upload subject. This task, which uploads your subjects, your final process data, onto the Zooniverse platform. So in the middle, you could have some other tasks. Let's talk about what some of those are. Here is where I keep my tasks in this operations folder inside of Thea. So we have our GIS operations. This includes things like computing corners, which is a task that we use to translate between our WRS rows and our latitude and longitude. Because sometimes the researchers need the latitude and longitude numbers in order to be able to put the location on, say, a Google map or a Mapbox map. So then in image operations, we have composing the images. This is where we might compose all of the channels that we've taken down from the NASA Landsat service into a visible image or into another composition. We might resize the image. This is changing the size of the image. Or we might tile the image, which is chopping up one of those huge images into smaller tasks. Now, what's special about this image processing pipeline is that it should be customizable to individual researchers. Usually, researchers have to make a custom script with all of the tasks that they need to do. They develop it over time, and they have to keep that somewhere. It can be brittle. It might be difficult to update, particularly if the researcher who wrote it leaves and another researcher has to come on and update that thing without any prior context as to what's in that script. In Thea, what should be possible is that a researcher would be able to customize their specific pipeline and say, give me a pipeline stage that does my downloading. Give me a pipeline stage that does my composing, that does my tiling, that does my resizing within a convenient UI. Now, we have not built a UI yet, and so the little hack that I've been using in the meantime is something called the Django admin console. So let me show you the Django admin console. This is available on all Django apps. And if I run the app locally and I go to admin, I'll be able to go on here and log in. This is my work login. And so what you can see here, and this is available to you on any Django app out of the box. So you can see my models here that I have registered with the admin console. And the way that you do that inside of Django is, let's take a look here. So inside of my admin.py, I have registered my models for my admin console. This is what you have to do. This is it to get these models in your admin console. So the way that I make a pipeline right now is I go into pipeline stages right here, and I create pipelines with this add pipeline stage button right here. You can do this with any model you've registered. So you'll notice that I have a few here. Floating forest replication stage 1, that's a composing task, a tiling task, a resizing task, and then an uploading task. These are those process bundle tasks that I talked about before, and all of these tasks belong to my example image project floating forest replication pipeline, which is the pipeline that we ran when we made that imagery request earlier. So let me now show you my worker thread here. This is my worker thread. I've run this with pipenv run worker. We're using celery workers to run our tasks asynchronously. What you'll notice here is that what we have is a lot of wait for scene tasks in succession right now. So the way that we get the image process, the way that we get the images down rather, is that we request them from NASA's ESPA service, which works a little bit like when you order your coffee inside of your cafe coffee line. You stand in line and then you make your order. When we press that post button, what we did is we said, I would like a large latte with almond milk, please. I would like images from this part of the world, please. And now what we're doing is we're standing over at the coffee counter and we're waiting for our images to come down. You'll see that we just had a process bundle task come through. So it looks like our images have come through from ESPA. So we've now received our coffee. But what we did for the first few minutes of this video is we waited for that coffee to get ready. ESPA was preparing the images. It was searching for matching scenes for us. And that takes a little bit of time, both because it's a lot of data and also because there may be multiple requests queued up before us. So if there are other requesters who've done a number of jobs, and let's say ESPA was down, it comes down for maintenance, usually on Wednesdays in the middle of the day, about once a month. After that, these processing pipelines take an especially long time to run because a lot of requests have been queued up from other requesters around the world, and we have to wait in line to even order our coffee. So this will take anywhere between 10 and 25 minutes waiting for our scenes until we finally get to process. In a future video, we're going to go over how to reduce that wait time so that I can run tests with a faster feedback loop, which, as we've talked about, is extremely important for effective debugging. So the tasks will run in here, and in the meantime, over here, I have my console open where I'm running my application. Eventually, when my application has run this entire set of requests, then my images will appear on the project, which let's see if I can get it up and show it to you. Here we go. So this is my project inside of the Zooniverse, and these are my subject sets. This is where my data uploads after I've processed it. And what you can see here is for each of these individual subject sets, we have all these images. What are these? Well, they're the tiles that we talked about. And so, apologies for the wait. My thing is running a little slow right now. And it looks like this image may have been taken at night, or it may be one of the images that just appears dark over the ocean or over land. But this is one of the tiles that we've created from that data that we received down from ESPA. Now, let's take a look at what an ideal version of one of these images might look like, because I want you to understand what we're going to be able to automate. So let's take a look at floating forests now. This is the official production project, and what you're going to see are these beautiful images of kelp along the coastline. It's going to take a minute to load. Like I said, internet's not great right now. But let me tell you what is happening here. So you see this kelp? So these are the images that we might see. Hopefully it'll load for me. So here you see some coastline, and you would be drawing little kelp around these coastlines if you see it. Now what you'll see here actually is a discussion about whether we see kelp in this image. But what somebody's done here is they've zoomed in to determine whether kelp is visible right here. Let's see if I can show you some other images that you might see. Maybe there will be some images in here. Let's see. So let's look at the results here. This is results that we've published. Let's see if we can classify. And this is what you would see if you were going on and just looking for images. You would come in here, And so you can see images here. It looks like this one is over the ocean. We're going to say there's no kelp in this. Hopefully I'll find one with kelp. Ha! Okay, so check it out. This right here, this is a kelp patch. And so we would get an image like this, and we would be able to ask people, hey, do you see any kelp patches in this image? We've done all the processing on those NASA Landsat images to be able to create tiles like this, where you can look at a coastline and take a look and see if you see any kelp. Okay, so why do we need our image processing pipeline if we already have images like this? This is the Floating Forest Production Project. And like we spoke about earlier, this is a team that has currently a script that they use to do their image processing. They've spent a lot of time and effort making that script. And ideally, it would be much easier for them to create, modify, and maintain that script if they had a UI like this one instead, to be able to modify, add, and remove tasks from their pipeline so that they can process images. Or for example, if they have this pipeline that works for them, and then they want to get their images from an updated satellite, say they're switching from Landsat 7 to Landsat 8, and they want to change the way that they tune the green channel, or they want to change the way that they tune the contrast on their images, because the images that come down from Landsat 8 are just a little bit different than they are from Landsat 7. In order to do that update, rather than having to go into the script and find things, they would be able to come into a task that increases or decreases contrast, and they'd be able to change some numbers in there and click this save button, and that would be all that they had to do. Now, where are we on this image processing pipeline? We have a few tasks that work. We have some login functionality that works. And we also just got to the point this week where we can start to make some modular tasks. We can start to put tasks one after the other and move them around into an arbitrary order, which is extremely important for this application being flexible for other research teams moving forward. So now you understand a little bit about what our app does and how it works. And in future posts, we're going to start doing some things together, like creating tighter feedback loops for debugging, adding functionality to tasks, adding tasks themselves, and ultimately, hopefully, deploying this thing to production in a way that researchers will be able to use it. So hopefully a little later this week or next week, I'll be able to do a full live stream with you on adding some functionality to this application. But I wanted you to have a video that you could refer back to get a refresher on what this app is and how it works. And like I said, I'll include some additional background information in the description as well, so that you'll be able to look back and see, hey, what is this app? What are we using it for? When have we worked on it in the past? I can also link a couple of blog posts in the description where I've already done a little bit of debugging on this app, so that you can have a slower speed introduction to the way that I develop on this app before jumping into full live coding. I think that that's going to be it for today. Thanks so much for watching.